Thanks, Alberto, and thanks for the invite. I'm always happy to talk about citizen science games, so I'm glad to be here. As Alberto was saying, I used to work in video games for about 10 years, and now I work for a health tech company in the UK. So I worked in video games for a long time, and I really enjoyed the industry and working in games. But towards the end, I was thinking that I was not fulfilled anymore and something was missing. And this is when I discovered the game Foldit. So Foldit is a game that introduced me to science, and it made me wonder how games can be used for different purposes than just entertainment, like research or health. I'm also happy to talk about citizen science games to social scientists. There are not many citizen social science games, so I'm hoping that by talking about these games with you guys, maybe some people will get some ideas for future projects. Because you will understand people's behaviors, their thoughts, their feelings, you can understand behavior change. I think you can help designers create games that really motivate people. And as you will see, if you create games that motivate people and that really games that people enjoy, you will get more data and better quality data. So there are not many citizen science games and not many social science games, but they can have a big impact on players. So there is room for more games and room for closer collaboration between researchers and designers. It started raining really badly here, so I hope you don't hear the rain. I hope the sound is fine. So today we are going to be talking about citizen science games, and I will present 11 games to introduce different definitions or different ideas. We'll start with definition of citizen science games, and then I will show you what kind of task citizen science game can tackle. And we will also look at the different approaches to create citizen science games. At the end, we will review briefly some of the challenges and opportunities with these games. So I will use first Foldit to introduce citizen science game. And for each game, I try to put a short video to give you an idea of the gameplay. So Foldit started as a distributed computing program to predict protein structures. And that's the program that you see on your screen. So volunteers could download this program on a computer or PlayStation. And when the players were not using their computer, the program used the processing power to solve big computational problems. So talking about proteins a little bit, in our bodies, the protein fold into different structures, and the structure depends on the function of the protein. So, for example, hemoglobin carries oxygen in the blood, and it has a structure efficient for this task. Or insulin regulates the amount of sugar in the blood, and the same. So protein has a structure that is really efficient for this task. So knowing the structure of the protein is important to understand how it works, to understand its functions, and to help design drugs that can fix onto this protein and target them when they are not functioning properly. So with the distributed program, users could not interact. They could watch the protein folding onto their screen. So that's on the screen, you can see what they could see. And after a few months of watching this program folding proteins, some users came back to the developers and they reported that from time to time, the program got stuck in really improbable structures. And they told the developers that maybe they could do better than the machine was doing. So the developers listened to them and they developed a new program called Foldit. And Foldit is a series of 3D puzzles. They gave all the tools to users to fold the protein themselves and to search for structure. So instead of just being passive and watching a computer do the jobs, they were actively contributing to the research now. all the 3D puzzles are based on real scientific problems. Each puzzle has a goal, which is finding the most efficient structures. They've got some conditions, some winning conditions, some rules. There is a score for the puzzle, which is based on the energy efficiency. There is a leaderboard, so that brings an element of competition between players. And the players can also share their own algorithm. So they can create algorithms, share them. So there is some kind of collaboration to speed up the research again. So all these elements like goal, rules, conditions, score, competition, they are basic elements of game. A few years after the launch, there was a really good collaboration between players, scientists, and machine. And together they managed to predict the structure of a protein related to HIV. And there have been quite a few publications linked to this discovery. So to summarize citizen science games, they are games in which non-scientists can help solve scientific problems. There are different ways to contribute to research. And we will see that players can be tackling complex problems, or they can be producing data, or they can be helping with annotation, collection, or categorization of data. So now I'm going to review a few games and show you the different problems that are tackled by players right now. So a bit like in Foldit, in Eterna, the players are solving complex problems, and this time they are not folding protein in 3D, but they are folding RNA molecules in 2D. I don't know if you can see, but at the top middle of the screen, there is a small shape, and this is a shape that the players are asked to match. And they can change the sequence by swapping different RNA components and form new pairs. Some components are going to stick together and some other are going to repel each other, and that's how it's going to shape the molecule. So once again, some different puzzles have different conditions, such as the number of pairs that are allowed in this game. There are a few players who started publishing papers and peer-reviewed journal about their method to fold RNA proteins. Some others have been hired by universities to help design new molecules. And the scientists behind the RNA game are releasing some challenges on regular basis. And when they find good design of RNA molecules, they just take them to the lab to design them in real life. So the two previous games, Foldit and Eterna, are games that require a lot of computational power. And these problems could be solved with quantum computers if quantum computers were ready, but there is still some work to be done on them. So in normal computer, all the information is carried via bits. And these bits are composed of many different particles. So if one particle is lost, the information is still carried by other particles. In quantum computer, the computer relies on single particle to carry information. So if the particle is lost, the information is lost, and that can cause different kind of errors and even hardware failure. So all the errors must be corrected. So Dekodoku is a game to try to help fix these errors. And it's a mix between the game 2048 and Sudoku. But the difference between these two games and Dekodoku is that we do not know the winning strategy. So if you play 2048 or Sudoku, if you train, you will develop strategy and you increase your chances of winning. For Dekodoku, this is what we are looking for. This is the winning strategy. How do we play to make sure that we remove all the errors? So the screen is going to fill with numbers or symbols, and the game is to remove them as they appear. So looking for this game, players need to look at how far apart the numbers are, Do they belong to the same group? Or how do the neighbor react when the player interact with a group? So the previous games were about solving complex problems. And here, the See Hero Quest game is about producing data for research. So this is one of the most known citizen science game. It's a great example of collaboration between scientists who are based at UCL in London, and a game studio in London as well, and a Dutch company, Dutch Telecom, who funded the project. The game has been played like a few years. It was released a few years ago by more than 4 million players around the world. And this is now the largest study on dementia in history. So the goal of the game is to collect navigation skills in people. The reason for that is navigation skill is one of the first cognitive abilities that is lost in people affected with dementia. So testing navigation skill could maybe be a way to detect dementia earlier. But to be able to use navigation skill as a way to detect dementia, we first need to have a reference or a baseline. So we need to know how people of our demographics compare with us. So by playing the game, players have been creating the benchmark of human navigation skills. Part of the experiment was to study people who are genetically at risk of developing Alzheimer's disease. And the question was, can playing a few levels of this game be a predictor of these people being at risk of developing Alzheimer's disease? And the recent publication showed that yes, playing a few levels would be a predictor. So I guess in your research, you must know that your study will be about producing data or collecting new data, sometimes annotating, categorizing, labeling all this data. So for biodiversity, a developer in Australia created the Quest game. So it's a data collection game. The idea is that to protect and study species, we need to learn about the species, we need to know where they are, we need to observe them and map their distribution across region or across country, continents. So this team created the location-based game. Players go outdoors and they take pictures of as many species as they can. They try to identify them. So they get gold when they find a species, they get gold when they identify the species, and they also get more gold when they find rare species. From time to time, there is an event in-game where the developer will put some gold in different places, and then they invite players to go there and to collect data over there. To my knowledge, this is the only citizen science game that found a way to monetize, to fund itself. So players can pay in-game to unlock new challenges or to unlock challenges for friends as well. And all the information, all the data collected is shared with different institutions for research. This new game here, Mark to Cure, is more for data annotation and data labeling. So the goal of Mark to Cure is to identify different concepts and to see the relationship between the concepts in biomedical text. So the users are asked to highlight words linked to concepts such as disease, treatment, drugs, biometrics, and then they need to confirm the relationship between the different concepts that they highlighted. So for example, on this screen, you can see the concept would either relate to or not relate to or cannot be determined. So there is a lot of papers produced or knowledge produced each day. And this game is to help scientists find new information quicker, create new links, and accelerate treatment to rare genetic disease. So Mark to Cure is not really a game, but once again, it uses elements of gamification to motivate their participants, and that will lead to the next section. So we saw that citizen science game help scientific research. Some focus on solving problems, or some are more data oriented. And because it's not always exciting to annotate data, some scientists are starting using games or gamification, game elements, to motivate their participants. All the projects or games that I mentioned earlier are standalone ones, but we'll see that there are other approaches to link game and science. So here, this is about, this is toll catchers, and it's another example of gamification. So gamification means using game elements in a non-game environment. So in toll catchers, the players need to analyze blood vessels of mice affected with Alzheimer's disease. So the scientists want to answer questions about the disease and find a cure. And for each question, they need to analyze thousands and thousands of blood vessels. So most scientists already use machine learning, and they can already easily analyze the easy cases, but the most complex cases still need some human expertise. So some participants are intrinsically motivated. They want to help research because maybe they've got family member affected with a disease, or they just want to help research. But game and gamification can give external motivations. They can bring a sense of progress, or maybe some competence or mastery. So in this kind of project, the goal is always to increase the number of participation, annotation, and to increase the quality of the annotations to speed up research. So just also to give you some information about the mechanics as well. In this kind of games, there is always some kind of gold standard where a percentage of the blood vessel in toll catchers has a known answer, and this percentage of blood vessels is used to measure players' accuracy. So if a player shows really good accuracy in the known blood vessel annotation, then their contribution will be weighted more than if a player just started the game and hasn't done many contributions. So some people have been using gamification to try to make the task more fun, but some others have been thinking differently and thought that maybe instead of gamifying the task, maybe they could separate the task. So in Malaria Spot Bubble is a shooter game, and to unlock game levels, the player must classify some data. So they are shown images of a malaria parasite, and they must identify the species it belongs to. So there are different species of parasites responsible for malaria. And the question with malaria is, can we produce a low-cost diagnostic tool which can improve the health of millions of people? There are different scientists who took this approach. Cancer Research UK in the UK has been releasing a match 3 game. So the same, you play some match 3 games, and to unlock next level, you need to annotate some cancer cells. So another example of separation with game and the task is the skill lab by Science at Home. Science at Home is a research lab based in Denmark, and they've got a series of citizen science games in physics, quantum computing, in cognitive behavior as well. So with Skill Lab, they want to understand human interaction and human behavior. So they developed, on one side, a detective story, which embeds 16 cognitive puzzles. And the puzzles are allowing players to test their brain skills. They provide them with a map of their cognitive skills, showing, for example, visual attention, working memory, reaction times, etc. So the goal of this project is to understand how people solve problems and to try to stratify people in different categories. So they draw cognitive profile of players. They investigate how these players have solved different problems, and they hope to develop different personas and find patterns of learning within the different groups. This research lab is also really interested in hybrid intelligence, which is how to combine the best way possible human intelligence and machine intelligence. So we saw some people created games, some other people have gamified some project, or they separated the game and the task. And another way to which has been explored to date is integration of citizen science task inside an already famous game. So first developer who did that is the CCP. They developed the game EVE Online. EVE Online has been online for at least 15 years, and it has hundreds of thousands of players. And in 2015, they released a mini game in which the players were asked to categorize human cells. So it became straight away one of the most successful citizen science program and game, with millions of data annotated in the first week. And there was so many participation that the server crashed when they first released the minigame. They were so excited about the results that 2 years later, they released another iteration. And this time, the players are looking for exoplanets. More recently, another company has done the same than CCP. So now in the game Borderlands, so you can find a small arcade where puzzle can play with some gene sequencing alignment puzzle games. So in this case, what the scientists have done is tap into the large existing audience of players and have them contribute by giving them some reward for their game itself. So citizen science game help scientific research. We can focus on solving problem or collecting, annotating data. There are different ways to do it. We can gamify, we can integrate into different games, we can separate games and tasks. And now we look at some of the challenges of designing citizen science games. So first of all, to be exciting, the game needs to tackle a problem that is not solved yet. And if possible, it needs to be suited to citizen science. So citizen science, the projects that are successful in citizen science are usually involving large data sets, a task that's maybe not too complicated. And it should be a problem that is best suited for human or the combination human-machine. So right now, how humans good at that machine don't do well. We've got problems with pattern recognition and categorization. We are better at understanding images. Humans are better than machine with semantics, language. We are also really creative. So if the problem tap into imagination or creation, it will be better solved by humans than machines. And we are good at really fast approximate solutions. The research question needs to engage people. People are going to spend time to help solve the problem or to help collect data. And there is a lot of other way to spend time right now with games, with social media. So the question must be engaging. There is a need for a good understanding of the science behind the problem and how it can translate into a game. And then there will be some design constraints because in the end, it's about playing with scientific data and not just an entertainment game. Creating a game is quite expensive. So if the problem is scalable, then it's better than if you create a game for only a few annotations. So to defining a large data set is not hard, and there are many areas in science that could use large-scale human power. There are also lots of people willing to take part in scientific research, even in a small way. To increase the chance of success, it should be a collaboration between the science, expert knowledge in the problem, but also designer who can help find a way to translate a problem into a game and make it like engaging. You need to have a good communication and being able to communicate difficult concept to people who may not have background knowledge or expertise. In terms of the players themselves, citizen science is still a niche, and a bit like in games, the citizen science have their own ways. So in video games, a few players in a mobile game, for example, a few players will be spending a lot of money when other players will not be spending any money at all. And in citizen science games, a small percentage of the players will contribute to most of the research. So for example, 2 or 3% of your player base might contribute to 80% of the annotation. Some research have found that the motivators to contribute to citizen science is either an interest in science in the field or in the research question. It could be just a willingness to help or to contribute to a cause, or it could be about learning and developing new skills. Another challenge is about domain knowledge and transfer. So the scientists will need to express really complex problems into an understandable way. And the players should be able to contribute without having expert knowledge or prior experience. So designer will be here to help scaffold the learning. One of the things which is complicated sometimes is to make sure that useful data can be collected as early as possible in game. Some players will drop really quickly, but if the first contribution can be used, it's more contribution already. One thing that's going to be important is also to demonstrate that using a game will achieve better results than another mean. So we saw earlier that creating a game is really expensive. So you will have to find some funding, maybe companies or institution or grants that will be able to support the development. The last challenge for citizen science game is about balancing fun and science. If the game looks too much like a scientific illustration, it might intimidate some players. At the same time, citizen science is supposed to be science is serious. So if it's too gamified, maybe it's going to put off some other players who wanted to contribute. So a bit like in game design, you will have to find your audience and design with this audience in mind. So there is some challenges to develop new games, but still it's a good time to think about citizen science games. There are more and more large data sets. The concept of citizen science and citizen science game have been proven now, thanks to all the games that we reviewed. And also it's still pretty niche. So people who come and join citizen science project are usually really dedicated, and they do produce good quantity and quality data.